let me go to Ryan Melton. So as I say, there are two presentations from Ball Aerospace on two very different subjects tonight. The first of the two is by Ryan Melton, who received a Bachelor's of Science in Computer Engineering from Purdue University in 2001. He has been with Ball Aerospace for more than 20 years. Ryan started his career writing flight software for the NASA CALIPSO satellite, where he wrote the control software for the LIDAR subsystem and saw the satellite through the full life cycle from development to integration and test to launch and operations. He then worked on several other NASA missions, including GMI, Kepler, and the Ares rocket before transitioning to primarily working on ground systems. His Cosmos C2 system was first used supporting the SBSS mission in 2006. He later led the open sourcing of the Cosmos product in 2014, and he is currently leading the development of the next generation implementation with Cosmos 5.0. Outside of development, Ryan is also a functional manager within Ball's Ground and Flight Software Solutions, GFS2 group, and enjoys keeping up on the latest developments of all areas of software development and technology. And so with Ryan also, I heard some glowing estimates about the expectations to be had from Cosmos 5.0 from, I believe David was the one that provided this contact, and I very much thank David for this. Of course, I know Ball Aerospace very well, and we are very much looking forward to hearing from Ryan Melton. So Ryan, take it away.
Sure, thank you very much for the great introduction. All right, so I'm going to be talking about my next generation product here of Cosmos C2. I think you saw a little bit of Cosmos 4 this morning with David's presentation going over the OpenSat kit. I always talk fast. I got to calm down a little bit.
No, fast is fast.
Non-native speakers, I need to calm down.
No. They need to. That's their problem. No, we all. I love this. Faster is good. No problem.
Fast is good.
Yeah.
All right. So I do have slides. I'd like to just talk more, but we'll bring up the slides as well. So let me share my screen and see if that'll work for me. I think that's working. That's GitHub, but that's not really what I show. So here we go with my Cosmos presentation. Oh, and it didn't start at the beginning either. Fly back. All right. So as Fabio said, I'm Ryan Melton. I've been at Ball for 20 years. A surprising number of them have been working on this product. So back in 2006, I was on the SBSS program. One of my my managers kind of jokingly put out this requirement. He said, "Hey, wouldn't it be cool to have a elegant 3D gimbal model for our gimbal on the SBSS program? Or we could just display the values, the angle values, numbers." And I'm like, "Well, challenge accepted." So I went home and basically taught myself how to do OpenGL. I made this like really crappy looking gimbal that was just a couple rectangles that spun around, but it was a good start and it kind of fulfilled the purpose. I brought that into Ball, hooked it into a telemetry stream, and then it animated, right? So whenever the SBSS gimbal would look around, the OpenGL model would model it. And cool. So well then, I've got a system here that eats up telemetry and reacts to it. And that kind of was what eventually grew into the full command and control system now that is Cosmos. Dealing with telemetry is half the problem. The other problem is sending commands. And so it's actually very similar, honestly. And so it kind of went from there, but let's go through some slides. So what is Cosmos? Cosmos is the next generation of our Cosmos command and control software suite. So that does things like, send commands. You can view telemetry in different ways. You can retrieve and visualize older log data. You can do scripting. So you can kind of write simple programs that say, hey, send this command, make sure it worked. And then prompt the user for information as well, do interactive things. I like to sell this as not just aerospace. It's really kind of the slogan I came up for this product is the user interface for embedded systems. It provides you a way of talking to a group of disparate hardware. Often at Ball, we use this for integration and tests. So it's things like a power supply and the actual, satellite or, star tracker or whatever we're working with. and a bunch of like custom GS ground support software that's maybe a simulation of, ADCS simulation, and kind of it brings all those little pieces together into a single user interface, a single control panel where you can tell things what to do, take data, save all your data off, and kind of very importantly, log everything that's going on. So we log everything, all the data that's ever received, and we also log all the user interactions, and we log all the commands that get sent off to the pieces of hardware. So it's kind of the master user interface log keeping system, keeps track of everything that's going on. So different use cases, integration and test, board, boxes, components, payload, buses, complete satellites. There's a lot of other stuff I think this could be really great for. I'm personally kind of playing with it to do a home automation system or in like a home security system. Again, anything where you want to coordinate a bunch of different pieces of hardware in one place, it's really a really nice tool for that. Definitely ask questions as it go. I like I said, I talk fast and I kind of ramble, so ask questions as it go for sure. Don't be shy.
I do have one. So we just listened to OpenMCT, we listened to Cosmos, we listened to OpenSATKit, and everybody uses the word telemetry. Are these products redundant?
So it's interesting. I've seen OpenMCT a little bit, and I've actually got quite a few questions for those guys, hopefully when they come back.
Yeah.
It looks like a data visualization tool, and I'd definitely love to know if they've already integrated it with Cosmos, or if that's on the plan, or if it's something we can talk about. The goal of Cosmos is to be very open too. Like it's supposed to be an architecture and a framework that is easy to integrate other pieces with. And I think that looks like a nice, a different, like an alternative telemetry display tool. So definitely would like to talk to them about that.
So not redundant, but alternative. That would be it.
No. So as far as I'm aware, this is the only full-featured open source C2 product that is out there.
Right.
C2.
And sorry, C2 explain.
C2 stands for command and control.
Command and control.
Two C's.
Command and control.
Command and control. Yeah.
Remember that we have high schoolers possibly in the audience. So
yeah.
Thank you. And me.
These systems have different names. Sometimes it's C2. Sometimes it's T and C. Telemetry tracking and commanding, something like that. And there's a few other acronyms you'll see that all kind of mean the same thing.
Okay, sounds great.
But C2 is the one I like.
Okay, thank you.
Yeah. So this is kind of a history, and then I'll talk a little bit kind of like, so Jay just did kind of about the history and kind of the philosophy of open sourcing this. So again, I had my earlier story, SBSS story, about creating a animated model for my couch at home. I brought that into Ball, and we did our first internal release as just Ball software in late 2006. We used that part of the integration test effort on the SBSS program. Then over time, kind of through my own marketing and pitching, it kind of grew to replace all the other internal things that Ball had. And Ball had a bunch. We had one we were using a tool from Last called Oasis, which is actually one I built Cosmos directly to compete with. We had an internal one called GWiz that was based in LabVIEW, and Dynamite was another LabVIEW one. And there was a few other weird named ones that kind of lost to Cosmos over the years. And then we got to the point where we open sourced it, and that took a lot of work. I had a lot of convincing. Aerospace is really not an industry that historically has been very open to open sourcing. It's a very proprietary, do your own thing kind of world. And interesting enough, I came up with 7 different business models for why Ball should open source this product. Everything from being able to sell training to kind of just establishing a market of, we weren't really known for ground systems. I think we've been very successful through Cosmos of becoming known that, hey, Ball does satellite ground systems, and a bunch of other different business models. Basically, I had to convince management. It took probably net a year of convincing before I finally got permission to get this out there.
And so since you are eliciting questions, I'm interested, what was the objection? Is that something that you can share, or is it not possible?
No, I mean, there's always injections. Like the first question I get at every conference I speak at is, why did you open source this? Literally the first question I get always.
But because they think you could have made money out of it. I mean, is that
they think well, there's different. Yeah, you could be selling it as a commercial product. We could be just keeping it as a competitive advantage. There's different arguments, and those arguments still go on within Ball as well. But kind of like Jay said, if I hadn't open sourced this, no one would ever know about it. And honestly, I probably wouldn't still be at Ball. A lot of these projects start out as passion projects, and there's stuff that you really personally care about. And for people like me who are like innovators and really care about new technology and things, I care a lot about utility. Like, so my personal motivations outside of Ball's motivations are, I want as many people in the world to use this as possible, right? It's awesome talking to you guys in Turkey right now. That's just, it's my vision come true, right? It's this kind of stuff that I love. There's some guys down in Brazil that have done a whole CFDP layer on top of Cosmos. Guys in South Korea are using it. It's become an international product now, and I love it. It's been a great honor to be able to make that happen. So that's kind of personal motivators as well. Yeah, where was I at? Ball's put money into this over the years. They put a decent amount in 2013-14, and then in 2017, that was actually Ball Capital, so that was Ball Profit that they invested in it. In 2020 and 2021, we've been doing IRAD investments, and basically it's now become the default C2 system for all INT at Ball. So INT is integration and tests. That's kind of verifying all the stuff we build before we ship it off to get launched or to a customer, whoever's buying it. Unfortunately, this last line is still sad for me. It's primarily used in operations for companies outside of Ball. So Blue Canyon operates all their satellites with Cosmos. Capella, Lockheed Martin has at least one that I know of. Goddard has several now. Geneva Tech. There's other companies that are operating missions with Cosmos, but Ball is not yet operating a space mission with Cosmos. I can say we are operating some other stuff, but not space missions.
So you're saying that the competition uses your product that you outsourced, but you don't?
For actual on-orbit operations, Ball has not used Cosmos yet.
I see. Well,
which is still a pet peeve and annoyance of mine, but we're getting there. It's on several proposed missions. Mm-hmm. A lot of these guys like Canyon, they're small sats, and Capella's small sats. Lockheed mission that use it, I believe, is a small sat. A lot of the Goddard missions are small sats. Geneva Tech is university missions. So it's the small sat market has really been what has embraced Cosmos because it's free and there's nothing else out there like it. When you're building, $100 million billion satellites, there's a lot more hesitancy to do things differently. And so again, that's changing, but definitely the small set market is what has really loved Cosmos.
And just for us to understand, is the alternative to Cosmos a proprietary internally developed product, or is it a commercial product that we could buy if we wanted to?
There's only, I don't know if there's any that have advertised pricing. So competitors to Cosmos that are out in the industry are products like OS Comet. Neptune is in Naval Research Laboratory Op1. NASA actually has several. So there's Amos is the one that's probably most closely related to the OpenMCPT project. There's one called ITOS. There's one called Eclipse. There's one called Maestro. Historically, every aerospace prime kind of has their own one of these. And it just kind of comes along for the ride. So if you buy a Lockheed Martin satellite bus, you get the Lockheed Martin C2 system.
Uh-huh.
And it just kind of comes along for the ride, and that's kind of what you get forced into using historically. And Cosmos is kind of, we're the wild card kind of changing the game as far as that goes.
All right. Okay. I'm not going to interrupt again. Thank you.
Oh, ask questions. I love it. So that's the history. Like I said, it's been quite an effort to get it open sourced, and we definitely have experienced the same kind of, we've had probably 20 different contributors in the 7 years since I've open sourced this. Lots more people than that asking questions and saying, hey, this is broken, and that kind of interactions. But people actually contributing, like submitting code to the project, has been actually quite a bit smaller than I had hoped. And a lot of that is, again, the aerospace industry does not like sharing stuff, and they do not like getting permission to open source code, or even a patch from a company is very difficult, unfortunately. just kind of the reality of everything. All right, so what's new in Cosmos 5? So Cosmos 4, you saw that earlier this morning. Cosmos 4 is a desktop application built in Qt. You've been asking about programming languages. So Cosmos is going to add your next one, which is Ruby. Everything in Cosmos is in Ruby. There's a little bit of C to do some optimizations to make some stuff faster. But I guess the Cosmos backend is all Ruby.
You're kidding. Another one. Okay.
Another one. Yeah.
Okay.
Ruby and Python are so similar. Python has kind of won the war in several ways because of things like matplotlib and because of NumPy and the scientific toolkits that they have. And universities have really embraced Python, which is great. It's got some nice things. Ruby's still really good for web applications. So like Ruby on Rails, I'm sure you've heard of. Cosmos 5 uses that. But it's a language I wish would have embraced more of the scientific community. I think it would have done even better if it had.
All right.
So yes, the back end is Ruby. The front end is JavaScript. In particular, it's a technology called Vue, V-U-E. It kind of plays along with the Angular and the React kind of world. It's kind of the third player there. It's a really nice framework for building front ends. All right, so the open source, we got 2 editions now in Cosmos 5, though the second one is not really released yet. We've got our open source code. It's all out there. It does everything that Cosmos has always done: commanding, telemetry, visualization, logging, scripting, tables now. It's licensed under the AGPL v3. The AGPL is kind of a neat thing that's changed. Previous versions were the GPL v3. The problem with the GPL is that it has a loophole when it comes to web applications. So you can run, say, Cosmos if it was GPL licensed as a web application and not have to share the code because you're not really distributing. GPL is all about this distribution legal concept. If I give you something, I have to give you the rights to it too. Well, is a web page really giving users something? It's kind of gray, and so that's kind of a hole in the GPL. With the AGPL, it fills that hole and it says, hey, if you're running this as a web application, you have to provide a link to the source code. So with AGPL v3 licensing on the Cosmos web page, you have to, if you're going to modify it, and even if you don't modify it, if you leave it alone, there's a link that links to our GitHub page, and if you modified it, you'd have to provide a link to your code changes as well if you provided this web interface to users. So that's kind of the open source philosophy there. Enterprise Edition is going to be a paid product. That's where we take the open source edition and add enterprise-y type features like LDAP support, multiple user accounts, role-based access control. We also add in Kubernetes. I've got some slides on this. I think that's the differences, but basically it adds in kind of that next level that people would be willing to pay for, hopefully. But it doesn't take away any functionality that you would need to do a mission as an open source product. So it's really that when you've got a customer putting some hard requirements on you, that's what the Enterprise Edition kind of fills. Here's the things, like I said, role-based access control, end-to-end encryption, it supports Kubernetes, which is really nice for scaling. Scopes, you can have one server that runs multiple environments, and then better metrics and logging is on our roadmap. Same stuff. Let's talk about the architecture for Cosmos 5. So this is a whole new philosophy from previous instantiations where basically we're a monolithic desktop application, and with the prime piece of that being something called Command and Telemetry Server. That was a single desktop application that connected to all the different pieces of hardware that you wanted to talk to. It did all the logging to disk. And as you can imagine, that became a giant bottleneck where this one process is talking to all the other pieces of hardware, and it's doing all the logging, and it's the interface for all the tools, the other different visualization and commanding tools that I have, all flowing through this single point. And so that actually worked surprisingly well. I mean, it worked up to really big missions, but there are a couple programs we had where we had to kind of throttle the GSC telemetry a little bit just to keep it from basically using too much CPU on a process. So this new architecture takes that and it brings on all the modern buzzwords you can imagine. So we're using Docker containers. It's all microservices based. The Enterprise Edition does support Kubernetes. We're using open source database technologies. We're using both Redis and a product called MinIO. MinIO is an Amazon S3 clone. So that's where we keep all of our files. Redis is used for all kinds of things. It's used as a key value store. It's used as a streaming data service. It's used as a PubSub message bus. Redis is an awesome product. If you guys haven't played with that, I would highly recommend it. It is a great tool.
And while you go, would it make any sense to contrast the Cosmos 4 to 5? Is it a completely new architecture, or are they related in any way?
So I can get into that kind of on this picture. Like a lot of the source code from 4 is the same. So Cosmos 5 is configured almost exactly the same as Cosmos 4. So the config file format has not changed. So the way you define your messages, so a big part of Cosmos is, again, commands and telemetry. So you have to define that. So it has to know, what does a command look like? What is the binary data that makes up a command? What does the telemetry packets look like? It's basically like a C struct is kind of what you think of it. And so you have to call out, hey, this is this item called temperature 1. It's a unsigned 16-bit integer, and it has this conversion that, it's a polynomial that I run on that, and it turns it into a floating point Celsius value. So you got to kind of configure it. All that configuration is the same between Cosmos 4 and Cosmos 5. The biggest changes between 4 and 5 is the user interface went from a desktop application to a web-based application. So now your browser is bringing up the tools rather than having Qt dialogues pop up on your desktop. Other bonuses to that is you can install in one place and have 10 different people access it over the browser or their phone, as SJ demonstrated. There's a lot of advantages to web interfaces in kind of the maintenance aspect, and also cross-platform natively, right? Most of the other stuff is the same. Like the goal is to kind of replace the interface, make it faster and more scalable, which is what the microservice architecture does. And containerization has nice features too. You don't have to install anything on your host except for Docker. So before you had to install a Ruby, a local Ruby installation and a few other pieces. Now, if you have Docker, you can run Cosmos 5. So it enhances kind of the cross-platform nature as well with moving to this architecture. So let me talk about this picture a little bit. So on the left is kind of a set of green things here. They're the things that we're talking to. So in general, especially in Cosmos 5, that is data streamed over sockets, usually TCP/IP sockets. We also support UDP. I also support serial ports. One of the downsides of Docker is that serial ports, you can't get to them natively from containers. And that's caveated. On Mac and Windows, you can't get to serial ports at all. On Linux, you can if you run the container in privileged mode. Privileged mode is scary because then you could mess up the host, and so it's not good from a security consideration. So I've come up with workarounds for that. Essentially, you do a bridge, you run a little application on your host that can access the serial port, and then it converts that to TCP to talk to Cosmos.
Okay, and now I'm gonna ask you for a favor.
Yeah.
For us humans, can you give us hello world examples? Again, I'm thinking about, freshmen, high school seniors. Can you break it down to, if you wanted to explain to a 17-year-old what Cosmos is doing?
Well,
challenge.
I could jump to the demo.
Oh, really? Well, why not? I mean, it's your game. Yeah.
If you want to see a demo, we can go straight to the demo. So
I'm sure that you and David could go on for hours probably here. But I would like to keep the youngsters engaged by looking at something.
For sure.
Yeah. Okay.
So here's Cosmos. And this is Cosmos 5. This is the new web interface. And we've got basically a set of tools. We're at, 1, 2, 3, 4, 5. We've got 12 tools that ship with us now. It has a plugin based architecture to where you can write your own tools and get them to show up in that list over there on the side as well. I'm using a really cool technology called Single SPA, single page application. It's kind of a joking name, but you can write a web front end in Vue and Angular in
Single SPA.
Single SPA, yes. Single SINGL SPA.
No.
Single page application.
Okay.
Is the technology. This is what open source gets you, is all kinds of weird technologies. But but it makes it to where I can do dynamic tools added to the system. So every single one of these is a unique application that's all running in the same front end web application. And you can build your own, and we have built our own. So we've done things like added on a cesium Earth model super easily into this. Another company built a React app and injected that into that as well. So it's a really cool way to make this even a modular, you can add whatever you want into the Cosmos world using that technology. But let's get back to your example. Like, how would I actually use this? What would I use this for? So I don't have a perfect example here. This is one of the first things I open sourced since Cosmos 5 is I've got this little Wi-Fi plug thing. It's basically a Wi-Fi controlled outlet. And so I wrote a Cosmos plugin to control this guy. This guy puts back telemetry of, it says, hey, is the relay in here open or closed? How much current is this thing drawing? I'm sure if this version does. Some versions have current monitoring. And is it currently, is it currently on or off? And so with Cosmos, I can say, hey, talk to this little Wi-Fi guy, send a command that says, hey, turn on the outlet or turn off the outlet, and get back telemetry status saying, hey, is the outlet on or is the outlet off? That would be a super simple kind of hello world application. Now, I'm not sure if you're asking like, how would I configure that? I can dive into that too, if you'd like.
Well, no, this is a very good first step. I think I've never heard the phrase telemetry from an outlet. So this is, you've done a great job there with the hello world. Yeah, that's great.
Telemetry is just a fancy term for data coming out of something. So let's look at some telemetry. So this kind of is telemetry. So this is the Cosmos Command Telem server equivalent in the web version. This is kind of just your quick, hey, what am I connected to? If I want to disconnect, I've got some buttons to do that. I can see how many bytes have I sent to the device, how many bytes have I received from the device, how many commands have I sent to the device, how many telemetry packets have I received back from the device. So it's kind of just a feel, is data flowing? Kind of a unique aspect of aerospace is a lot of our systems just asynchronously spit out data. They say, hey, if your satellite says, hey, I'm here, hey, I'm here, hey, I'm here. And it's just, you didn't ask for that. It's just constantly spitting out stuff. So let's look at some telemetry. So that ADCS example, I've got an ADCS packet here. This is coming out of my pretend satellite. It is telling me, hey, my position XYZ are these values. My velocity is these values. I've got an attitude quaternion here. Got these values, and then a bunch of other stuff that's in here as well. So this is telemetry. It's just data coming out of the device telling you stuff. In this case,
can you explain when you say your pretend satellite, what exactly would that be? Like, are you simulating this is an end-to-end simulation? I mean, what kind of?
All right, so this is where integrating things with like 42 are way better simulations. This is just my Cosmos demo. So I just have a file that has a real orbit of position and attitude data that I'm just 1 hertz. Actually, this is 10 hertz. It's just spitting out the data from a file. So it's not really a simulation. It's more of just real data that's being replayed. If that makes sense.
Yeah. Okay.
So that's for this. Other things, I have a little crappy simulation. So if I look at, I do have some like pretend temperatures in here. So if we go to my health and status packet and I pick a temperature and add that to my graph, this is just a triangle wave, basically, that with time it's sending out a packet that says, hey, the temperature is 37, 47, 55, 60. And it's going to get up to close to 100, and then it's going to bounce down. And this guy just bounces up and down all day long. So that's the point of this demo is really just to give you something. When you install Cosmos, this is what you get. It gives you something to play with without having to actually connect to any real hardware. But it allows you to use all the different tools.
Can you inject noise in into these measurements?
Yeah. So I mean, the code that runs this little triangle wave simulation actually does a bunch of things. So if you look at this packet, I don't inject noise, but I do inject bad values. So if we watch, I'm not sure how frequently it does it. This guy will sometimes go to nan or infinity. And that's just basically proving out that Cosmos can handle nans and infinities and not breaking, which, back in the day it didn't. Another detail that's kind of interesting on this, there's the infinity that is popped in there. So I'm intentionally injecting those. You could inject noise. You can make it, not right now. It's a very clean triangle wave that just goes up and down. But you could change that simulation to be whatever, and that the simulation code for that is built into Cosmos and pretty easily editable.
And when you say editable by somebody who knows Ruby or anyone?
Well, it is written in Ruby, so that certainly would be helpful, for sure, to be able to edit that.
There isn't a way to drive the simulation through text files, for instance, like an input file then.
So all the packet configuration is just text files. So like how you configure all the data. So again, like this packet here has a set of telemetry points in it that's basically breaking up a binary structure into these individual values and giving you like a key value display. So let's go ahead and do that. Let's look at I'm not perfectly set up for this right now, but let's look at the code. Let's see if I can bring this up in Visual Studio. Maybe.
And I didn't ask you this at the beginning. You're running it off Linux?
So right now I'm running on Mac.
Mac.
Yeah, but this will, again, it's all Dockerized containers. So this will run on Linux, Mac. We've actually just got it working on ARM Macs, the new ARM-based ones. It should run on a Raspberry Pi. I have not tried that yet, though I have one that I just got. So I have a Raspberry Pi 4 that I'm going to try running this on. I haven't got there yet, but as far as I know, it should work. It does work on ARM Macs.
I see.
So it should work on a Raspberry Pi as well. It will not work on an Arduino. That's going to be way too underpowered. But
yeah.
The new Pi is probably a Pi 3 or Pi 4 should be able to run this. So let's look at this code, like the configuration. So you said hello world. That's a great point. This Cosmos C2 demo is included with Cosmos, and it comes with this kind of basic configuration of everything. So this is what Cosmos configuration looks like. Let me see if I can make this bigger. Get bigger. Hard. I don't know how to zoom without a mouse. Is this big enough to see or not?
It's okay for me. I mean, I can read.
Yeah, it's smaller than I would like it to be. I don't see how to change it. Sorry about that. So basically the config files are pretty simple. Basically it says, hey, append an item. It's called collects. It's a 16-bit unsigned integer, and it has a description. Hey, it's the number of collects. Right? The same temperatures. These are a little bit more fancy examples, but again, it's just a 16-bit unsigned integer, but it has a polynomial conversion that converts it from a digital counts, like off an A to D converter, into a Celsius value that you could show to users, since that's what that is showing. That's a pretty common pattern in satellites. You can have items with states. So here we have a thing called collect type. If it's 0, it's going to show you the text normal. If it's 1, it's going to show you the text special. You can explicitly declare that items have units, but that's basically it. It's like building up kind of like a C structure. That's how you define the packets so that Cosmos can know how to interpret them. It's just write a plain text file like this, install it in Cosmos, and now it can talk to that thing and knows what the data structures and knows what your packets look like.
Can you, when you say, again, to keep it as realistic as possible, so for that Pi that you have in your hands,
yeah,
can you walk us through what you would do with Cosmos 5 and that Raspberry Pi to use it in that?
Okay, sure. So to get this running on a Raspberry Pi, you'd probably have Raspbian or whatever the default OS is. It's just a Linux OS of some flavor that's on the Raspberry Pi. You would come down here and you would, git clone the Cosmos repo off of GitHub. So if you come over here to GitHub, Ball Aerospace Cosmos, you did this little fork. Oh, that's actually not the right thing to do. You would want to hit a clone, but I'm not logged in. If you're logged in, I think there's a clone button. But basically, you would git clone this repo. Then at your prompt, after git cloning it, you just type Cosmos control.shell start. That builds all the Cosmos containers, and then it starts them running in Docker. And then once it's up and running, you can type Docker PS and see the different containers. So now in runtime here, we have 6 different containers that are running the Cosmos application. We've got Redis and MinIO that I talked about earlier. Those are kind of our databases that are built into Cosmos. We've got Traffic, which is a load balancer. 2 different API endpoints. We've got a command and telemetry endpoint and then a scripting endpoint. I haven't shown you scripting yet, but that's a really important part of Cosmos. And then we got this operator, which is where a lot of the microservices get spawned, the ones that actually connect to pieces of hardware and do the data processing. All that kind of stuff happens in this operator container. But basically, so the steps for Pi would be clone from GitHub, install Docker. So you'd have to do the apt install or APK install or whatever Linux distribution yum install to get Docker installed on the Pi. Then you would do that little shell script I've had that says, hey, start it up. And then within probably 10 or 15 minutes, it'll build all the containers and be up and running. And then you just hit localhost or whatever your Raspberry Pi's IP address, port 2900, and you're here running the Cosmos demo just like I am right now. And that is all documented if you go to cosmosc2.com. We've got a really nice website. There's a little 9-minute demo of me talking about it down here. But if you go into the documentation section and then installation, that directions are all right here. It's basically download, extract, maybe set some environment variables, and then run this Cosmos control.bat or shell if you're on Linux or Mac. So the Pi would be the shell one. And then you're off and running. All right. wait for it to build and then connect your web browser. Basically exactly what I just said.
Yeah. Okay.
So it's very easy to get up and running. And if you have any problems, definitely submit a ticket on the GitHub page or just email cosmos@ball.com and we'll help you out.
Okay. I wanted to ask, Cosmos is part of OpenStackKit, right? I mean, 4.0.
Correct.
Will there be an effort to, I don't know who should do this, but if is 5.0 going into OpenStackKit? And maybe David is around here still, I don't know. I'm wondering.
So David and I just started talking about this, and I've offered to do the porting. We'll see what happens. Definitely, those guys doing it would be better, just so they can learn it too. I mean, part of doing that is the learning aspect. One of the things that was holding them off was Table Manager. We didn't have Table Manager until a couple weeks ago. Table Manager is a tool for editing binary configuration files. So they use a lot of those in CFS to configure their flight software. And now that we have Table Manager built into Cosmos 5, you can actually do that now, which is good.
So the answer is that you expect in the future to have 5.0 inside of OpenSDK.
I hope that is the route that they choose to go.
Mm-hmm. All right.
I'm still online, so yes. So no, yes, that is the plan.
Okay.
And if I can steal 30 seconds of Ryan's time.
Yeah, I would love that.
One of the challenges I have is as I'm demodular or I'm breaking the current OpenStackKit apart, I was mentioning I'm putting all the apps all the CFS apps. The CFS apps, this is something Jay alluded to. They're kind of there's the framework has advanced to a new big release called CALIPSO that has changed some APIs, but the apps have not been gotten through the open source release at Goddard. So part of my goal, once I break up OpenStackKit and make it more modular, I have my core bundle is using CALIPSO, but I don't have all the apps to go with it. And I'd kind of like to make one transition. So I don't have to, but it'd just be kind of nice. So yeah, but I'm definitely going to go there, especially after I've seen it now twice. It's definitely the way to go. So
okay. Yeah.
Thank you for adding table manager. Appreciate it.
Yeah, you're welcome. You were one of the drivers, not the only one, but definitely one of them.
Yeah. The other question is, what's with the microphone, Ryan? Are you a singer or something? I mean, what is going on?
I'm not actively doing it right now. I did have a podcast for a little bit, and that's what actually got me to buy this whole setup.
That mic rocks. Yeah. Wow.
It's good. It gives me kind of the radio voice.
Yeah.
Which is what I'm going for. So
do you have a preamp with the valve instead of the transistors? I mean, do you have a
no? So this is actually a newer one. So the best mic out there is also a Shure, but it's like a $400 Shure. This is a USB version of it. This is Shure M7 or whatever, and so it has all the preamp and whatever built in, and it's just a USB connection that goes off.
Wow. All right. Sounds good. Okay. So what I would think is this. Let me make if this is okay for everyone. I'm thinking having swapped